Okay, so we're practically done with the course. So we're here. I'm going to finish up what I need to do from 5.5. So if there are questions from 5.5 that you want to ask, be ready. I'm only going to do maybe 5 or 6 questions. Then the rest of the time I'll let you ask stuff. Okay, so we're here. I did some last time. I'll do more. 1 to 71 odd. Skip 61. Okay, some are definite integrals. Some are indefinite integrals. Okay, just a reminder, our exam is Thursday, not Friday. The usual rules, you turn in your homework, you have to have at least 70% of the homework done in order for me to grade your exam. Then your homework, quote unquote, for Friday is ask me questions about previous exams. And then that's the end of the regular semester. So final exam schedule next week. We don't meet Monday, we don't meet Tuesday. Final exam is Wednesday. Please note the starting time is 11:10 to 1:40. So I'll send to Canvas announcements the exam around 11 o'clock-ish, and you have until 1:40. And I also sent through Canvas announcements my office hours next week. I mean, some of them were Thursday and Friday, and that's after our final. So I know it doesn't make a whole lot of sense, but I'm legally required to tell you. So I told you, and that takes care of that. Okay. All right. So think of any questions you might want me to go over in 5.5, and then tomorrow we'll take any other section. Okay. So here we go. 45. I haven't shown you anything like that one before yet. So 45. 1 plus x over 1 plus x squared. The problem with 45 is that the derivative of the bottom is not quite the top. The derivative is 2x, but you have 1 plus x. So there's no easy way for me to account for that. Okay, so there's a trick you have to do. The trick is to break this up into 2 integrals. Okay, so I'll break the fraction up into 1 over 1 plus x squared plus x over 1 plus x squared. Right? So this is the same thing. Remember, a lot of your operations in math are both directions. You probably went from this direction to this direction a lot in algebra, but you didn't go backwards. But you're allowed to, right? I mean, take a look at this. You would say, oh yeah, common denominator, 1 plus x squared, 1 plus x squared, just combine the top. But you can go backwards too. I mean, if this is equal to this, that means you can go backwards from here to here. Okay, so what I'm going to do, whoops, dropped my paper. I'm going to break this into 2 separate problems now. The original I, so I stands for the original. I'm going to break it up into I1 and I2. It's almost as if to say, I'm going to take a timeout, figure out I1, and then separately figure out I2, and then put them together. Okay, what is this one? Inverse tangent of x plus C1. Why C1? Because this is going to have a C2. But yes, in my final answer, when I put C1 and C2 together, it'll just be C. But very technically, you can't call this plus C and you call this plus C, because if I call this plus C and I call this plus C, that implies those C's have to be equal, but they do not. So that's why I'm calling them C1 and C2. Now, so that's I1. I1 is inverse tangent of x plus C1. Now, this one is a regular substitution, right? The derivative of 1 plus x squared is 2x. I don't have a 2, but I know how to remedy that. So I2, u equals 1 plus x squared. Du is 2x dx. Put a 2 inside, 1/2 outside. So I'm going to have 1/2 integral of du over u. That's 1/2 natural log absolute value of u plus C2. Change u back. U was equal to 1 plus x squared over here. 1/2 natural log absolute value of 1 plus x squared. Okay, and now, in this particular instance, since 1 plus x squared is always positive, I write it as parentheses. In fact, I'll be stronger. You should write it with parentheses. It's no longer needed. It's just like our previous quiz where we had absolute value of 5. What's the absolute value of 5? 5, so you should never leave your answer as absolute value of 5. It can be simplified to just 5. Okay? So in this case, absolute value of 1 plus x squared, you don't need the bars because 1 plus x squared is always positive, so write it as parentheses. All right, so finally I is I1 plus I2. So my I1 was inverse tangent of x. My I2 is plus 1/2 ln parentheses 1 plus x squared plus C1 plus C2. But now that I have an arbitrary constant C1 plus another arbitrary constant C2, I can now just go ahead and say plus C in the final answer. Okay, so there we go for that one. Okay, so the key idea for this one is break it up into two, into 1 over 1 plus x squared and then x over 1 plus x squared. Okay. All right, so that was 45. Next, I was going to show you 47. And the trick for 47 is very similar to the one I did yesterday, where I moved around the square root one. Let's see, which one was that one? Can't find it right. Oh, it's 67. I did 67 yesterday. It's sort of the same theme. X times 2x plus 5 to the 8th power. Now, the derivative of 2x plus 5 is not x. Okay. So what am I going to do? I'm going to do a substitution anyway. Okay, the thing to the 8th power isn't nice, and this is nice. My goal is to change it so that this one is not nice, but this is nice. I want to have u to the 8th, and this can be semi-complicated. I don't really mind because it's being raised to the first power. Okay. One thing you definitely don't want to do is to multiply this out. That's crazy. Nobody wants to do 2x plus 5 to the 8th power. Okay. So I'm going to say u equals 2x plus 5. du is 2 dx. Put a 2, half. That's usual. Now, I need to substitute for x. Solve for x here. That's easy. U minus 5 over 2. All right, how do I solve for x? Subtract the 5, divide by 2. There it is. So my integral becomes 1/2 x, u minus 5 over 2. And then instead of 2x plus 5 to the 8th, u to the 8th. And then 2 dx is my du. So take a look at what happens when I did that substitution. This is easy. This is not easy. It got changed to the outside was not easy, the inside was easy, but that's what I want. I want u to the 8th. This is more complicated, but that doesn't bother me. Okay, so nice, not nice. I have not nice to the 8th power. I'd rather have nice u to the 8th power. This is not nice, but that's fine. See, the whole idea is, do you want to raise that to the 8th power? No. Let me make this complicated because I'm raising this to the first power. And now that's very easy. Take the half times this half, so 1/4 in front. And then just multiply u minus 5 times u to the 8th. So that's going to be u to the 9th minus 5 u to the 8th, and there it is. Now it's going to be fairly easy. Okay, so by making that substitution, instead of having something complicated to the 8th power, I just have a single letter u to the 8th power. This was not complicated. It became complicated after I substituted, but at least it's only raised to the first power, right? See, this is raised to the 1, so that doesn't bother me. All right, the rest is fairly straightforward. So 1/4 u to the 10 over 10 minus 5 u to the 9th over 9. This is plus c because it's an indefinite integral. Okay, so distribute and substitute back. What was u? U was 2x plus 5. So this becomes 1 over 40, and this becomes 5 over 36. 5 over 9 times 1 over 4. Okay, so 1/40th, 2x plus 5 to the 10th, minus 5 over 36, 2x plus 5 to the 9th, plus c. Okay, so that's it for 47. Okay, then I was going to show you 35. Radical cotangent x, cosecant squared x dx. This is almost tailor-made for you because what was the derivative of cotangent? Negative cosecant squared, which you almost have except for the -1, but the -1 doesn't bother me. Okay, so u equals cotangent x. Du is negative cosecant squared x dx. The original just had cosecant squared x dx. No worries. Multiplied by -1 inside and a -1 outside. Again, by doing this step, I'm multiplying the entire expression by 1 in the form of -1 times -1. But I need a -1 here because I can't change this to du until I see exactly a -1 times a cosecant squared x times a dx, which I now see. So now I can erase all of that, replace it with du, replace the cotangent with radical u, and there's a minus out in front. Okay, so I have negative integral of radical u du, and now it's fairly straightforward. So of course that's u to the half, negative in front, so negative u to the 3/2 divided by 3/2 means times 2/3. And it's an indefinite integral, which means plus c. Remember, for definite integrals, which I'll do shortly, you don't need the plus c anymore. And I'll change u back to cotangent. So final answer, negative 2/3 cotangent x to the 3/2 plus c. All right, then I was going to do a couple more definite integrals for you, 69 and 71, and then I'm done. Okay, so I'll be done in just a few minutes, folks. So if you want to start putting in the chat any other problems you want me to do from 5.5, let me know. But I'm going to do 69 and 71. Okay, so if you want me to do others, go ahead and start putting in the chat now if you wish. Okay, so 69, definite integral. What's the answer to a definite integral look like? A real number. 2. 71 is a definite integral. So there's a definite final answer as a number, ln e plus 1 or whatever. Okay. For indefinite integrals, blah, 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 plus c. You're doing the same process. You're still doing the anti-differentiation. Okay. So for indefinite integrals, just find me the antiderivative integral and then put plus c. For definite integrals, right, you're going to be plugging in stuff. But now with substitution, you might have different limits. So in other words, you may not be integrating from 0 to 1 anymore, or from e to the 4th anymore. Okay, 69. E to the 4th dx over x radical ln x. Okay, do you see a function with its derivative? Yes, derivative natural log of x, 1 over x. You say, I don't see the 1. Well, you can always put in the 1, right? 1 dx, so there's 1 over x. So u equals natural log of x. There it is. So my next step, that's going to be radical u in the denominator. Du is 1 over x dx. There it is, 1 over x dx. So this is going to be my du. I got radical u. And I'm even changing the limits. E and e to the 4th, those are limits for x. I want to find the corresponding u values. So the new problem will have u, du, and even the limits are going to be for u. So I don't have to go back to the original x anymore. Let's plug in. If x is e, u is natural log of e. Natural log of e is 1. Okay. A sneaky way you can do that is you can write e as e to the 1. Okay. And then ln and e cancel out, so you have 1. Plug in e to the 4th. Right there. So u is ln e to the 4th, ln and e cancel out, so you have 4. Okay, so instead of having this clumsy e and e to the 4th, my new integral is going to be from 1 to 4 of du over radical u. Okay, so let me show you. So there it is. Now we're pretty happy with what we have. Everything is u. I got u, du. The limits are also u. I do not have to go back to the original x. For indefinite integrals, you always go back to the original, right? You temporarily have something with u, but you're not plugging in any numbers. And your answer is plus c. You can't leave your answer with a u. By the way, these problems, the answers aren't with a u either. Your final answer is a real number, right? But, I mean, it wouldn't make sense for you to stop like over here, right? How can your answer have a u when the original was with x? So that's why you have to switch back. But for definite integrals, you do not have to switch back. Just leave everything with a new variable. Okay. So this is u to the -1/2 du. Right. 1/2 because it's a square root, negative because it's in the denominator. Okay, so we played this game before. So the integral of u to the negative half is u to the 1/2 divided by 1/2. Divided by half means multiplied by 2. Funny looking s moves to the right side, straightens out. 1 to 4. And yeah, u to the 1/2 means square root. So 2 radical u. Factor out the 2. Square root of 4, nice. Minus square root of 1, also nice. So it's 2 times 2 minus 1. Well, 2 minus 1 is 1. 2 times 1 is 2. So the final answer is 2. Okay, the problem's finished. I'll dig deeper though. What does that 2 represent? It's the area under the curve, whatever this weird thing looks like. Y equals 1 over x square root of ln x from e to e to the 4th. Real weird numbers. The area though is exactly 2. All right, finally 71, and I'm stopping with 71, so I'm done in a few minutes, folks. So if you want to ask me questions, you may. Otherwise, we're finished. And tomorrow, you can just ask me questions anywhere. Okay. So again, a quick reminder for the test. It's Thursday, not Friday. And Friday, what do? You can ask me questions and review for the final exam. That's the reason why I want to do that. Again, I'm not promising you. Whoops, here. I'm not promising you I can get the exams back to you by Friday, but I'll at least have the solution video, so you can look at the solution video and you can grade yourself, I suppose. And maybe I'll finish. If I don't finish by Friday, I should have it done over the weekend, which is normally what I do. Okay, so you should be able to have the last exam in preparation for the final by Wednesday. Okay. All right, 71, and I'm done. E to the z plus 1, e to the z plus z dz. Okay, now you say, how do I substitute? Well, which one is the derivative of the other? Right? So is the derivative of e to the z plus 1 that? No, it isn't. Derivative of e to the z plus 1 is e to the z. Is the derivative of e to the z plus z e to the z plus 1? Yes, it is. See, that tells you how to substitute. Right? You're looking for a function and its derivative. Here's the function whose derivative is exactly that. So that tells me the way to go. So I don't want u to be this, because the derivative isn't that. So let u be the bottom. E to the z plus z. Du is e to the z plus 1 dz. Perfect. So this is going to be my du. This is going to be my u. The 0 and the 1 are for z. Now let's see what happens for u. So plug in z is 0. Put a 0 right there and there. E to the 0 is 1. 1 plus 0 is 1. So u equals 1. And if I plug in z is 1, I have e to the 1, which is e plus 1. So u equals e plus 1. E is like 2.7. So 2.7 plus 1. So I'm integrating from 1 to 3.7 roughly. Okay, so here's a new integral. E to z plus 1 dz, that's my du. E to z plus z is my u. And what are my limits? I'm no longer going from 0 to 1. Those are the limits for z. What are the limits for u? 1 to e plus 1. How did I get that? Here's the relationship between u and z. So when u goes from 0 to 1, I'm sorry, when z goes from 0 to 1, I plugged in to find what u does. U goes from 1 to e plus 1, 1 to about 3.7. All right, this is my natural log. Remember, you can pretend there's a 1 there, 1 over u du. Okay, so ln absolute value of u from 1 to e plus 1. And again, ground rules again. If you're taking the absolute value of a quantity, which is always positive, drop the bars. Same issue in the quiz. So I may have let it go in the quiz, but I'm not going to be as generous on the exam. Right? You don't leave your answer as absolute value of 5, for instance. Absolute value of 5 is 5. Okay? Now, e plus 1, 2.7 plus 1, is that dead sure positive? Yes, it is. Put parentheses. ln absolute value of 1. What is the absolute value of 1? 1. So you shouldn't leave it with bars, right? So no bars there, no bars there. Okay. And by the way, ln of 1 is 0. So drop that. Final answer, ln e plus 1. And there we go. And in case you're wondering, no, you cannot do any more with that. Okay. In case you think, oh, can I do ln e? Not when you add stuff. Okay. There are properties when you multiply stuff. Like if you have e times blah, 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 there's a property. But not when you have a sum, ln of a sum, just stop. That's it, ln e plus 1. And that's that. Okay, I am done, folks. So that's all I have. You may have some questions about other problems. It's up to you if you want to do it or not. So let me check the chat. And I see nothing in the chat. I see something in the chat now. Okay, so if you want to ask me stuff, you can unmute yourselves or just put it in the chat and go from there. Okay, 5.551 was asked for. So let's see what that's about. 5.5, whoops. Keep this falling apart of me. 5.551. 5.545. Okay, I'm going to move the chat over. So I won't be able to see all of it, but I can see part of it. Okay, 5.551. Looks like that. All right, and as I mentioned all throughout the class, anytime there's a graphing calculator icon, ignore it. So just integrate. So maybe just stop right there. Evaluate the indefinite integral. And never mind about all the other stuff. All right, so do we see a function and its derivative? Right. Derivative sign is cosine, but I don't really have cosine. I have e to the cosine. So I should let u be cosine instead. So u equals cosine x. Derivative of cosine is negative sine x dx. That means I need a negative 1 inside and outside. No big deal. Negative 1, negative. So I is negative integral of e to the cosine x is now e to the u. And negative 1 sine x dx, negative 1, negative means negative 1, sine x dx is du. That's pretty much it. So negative e to the u plus c, change u back to cosine. So negative e to the cosine x plus c. And of course, you can double check by taking the derivative of this. The derivative of this would be same thing times derivative of the exponent. Derivative of cosine is negative sine. That negative will cancel that negative, and you have that. Perfect. Right? So it works. Okay, 45 was asked for. 45, did we not just do that today? Yeah, we did 45. That was the first one I did, wasn't it? Or wasn't it? Yeah. So, yeah, we did 45, did we not? Okay. Or if you missed it, you can get the video. So that's that. 63 is asked for. Let's see. Zero to 13. Dx cube root 1 plus 2x squared. Okay, so I don't want this mess. I want just u. So u equals 1 plus 2x. Du equals 2 dx. I don't have a 2. I put in a 2. Half. And 0 to 13, that's for which variable? Clearly it's for x. Now I need to see what happens for u. So when x is 0, u equals blank, and x equals 13, u equals blank. So let's see. So when x is 0, 1 plus 0 is 1. 13, 2 times 13 is 26, plus 1 is 27. So my new integral is not going to go from 0 to 13. It's going to go from 1 to 27. Okay? And I can see ahead of time that's going to be nice because I'm going to be taking a cube root. I can take the cube root of this, and I can take the cube root of 1 also. Okay, so my I has 1/2. Integral is now from 1 to 27 of 2 dx. What is 2 dx? Du. Over u to the 2/3. Right? Replace 1 plus 2x with u, and square here, cube here means that. And of course, we know that means u to the negative 2/3. U to the negative 2/3 du. And then we're home free. So my pen is running out of ink. So that's why I got lots of other pens here, hopefully. Okay, u to the minus 2/3. U to the 1/3 divided by 1/3 times 3. This is a definite integral, so don't need the plus c. The funny looking s moves from the left side to the right side and straightens out. And this becomes 3/2. U to the 1/3 means cube root. 1 to 27. The 1 and the 27 are for the variable u. I do not have to go back to x for definite integrals. Okay, the whole idea is change x and dx and these limits in x to u, du, and limits in u. So I no longer need to switch back to x. All right, so 3/2 cube root of 27, that's nice, minus cube root of 1, that's nice. So cube root of 27 is 3. Cube root of 1 is 1. 3 minus 1 is 2. 3/2 times 2 is 3. Final answer is 3. So there we go. All right, and let's see. I think I caught up from the chat. So any other questions, please? Otherwise, we can call it a day. So tomorrow, your homework is to ask me any questions from all of Chapter 5. And of course, that includes 4.9. 4.9 is part of it also. Okay, anybody else, please? I'll wait a few seconds. Anybody wants to put something in the chat or unmute yourselves? Okay, I don't hear anything, so we're done for the day, folks. All right, so have a good day. Tomorrow, we'll review for the test on Thursday. All right, have a good day, everybody. Bye.